So what I will do now is I will set up this small package on my computer in front of you, so you can do it. You can do it too. So I make search on InCASMATLAB. And you come to this to our NERSC website, and you can see the two sort of versions. The last one, the one before last, and the very last. So you download this latest version. Say in some location. So that's how download this goes. Now you go to this location. Here's this code compressed. You uncompress it. Go inside the directory, look at the readme file, readme file. So go through it, but you can just pass everything to section 5. And so what you see here is a number of examples. And you can write first 1, 2, 3, 4, 5, 6, 7, 8, 9 examples straight out of box. And also some examples at the very end, but the examples with the quality just models. It's first 1, 2, 3, 4, 5. This quality just models. To run them, you need to download some initial sample files from which you start your ensemble code, also from our website. So if you want to run those, you need to go to the QG samples directory and download what is the, and then follow instructions which are here in the readme files. But right now I will just run one of those examples. So I start MATLAB in this directory and copy, say, this the example number 3, which is with 40-dimensional Lorentz system, and just run it out of box. So what we see here is how actually the model state changes in time. Here, so one line is the true solution, another line is our state estimated, and the axes are actual observations. So you can see that the observations, the model is constrained to much better precision than the observations, than the error of the observations is. And that's the final state. That's the diagnostic window which I showed before. So I've just gone through all these stages and demonstrated how you can simply set up the system in 1 or 2 minutes.
Thank you. We try that. If you want to have questions now, you can ask them.
But you need to have MATLAB on your computer, which is sort of the downside.
Just through the website.
Web search.
Oh, that's the
And get MATLAB.
So you're welcome to try it, see what you can get something out of that. And if you have questions, ask Pavel in the next few days. Okay, so for the extra exercise that we will start next week, Olivier will get some updates, but he will tell us briefly what it will be about.
Yes, okay, bueno. Paris a package of didactic software for assimilation of simple systems, but it was not in a format which would allow easy use by external users. So my collaborator David Pinier has adapted them, is adapting them so that's hopefully usable either the day after tomorrow or next week. It uses MATLAB, so you must have MATLAB on the computer to use, and it implements a number of variational algorithms on two simple systems, a simple damped mechanical oscillator and the famous three-parameter Lorentz model, which is a simple example of a chaotic system with a strong sensitivity to initial conditions. And the algorithm which I implemented are variational, well, so-called optimal interpolation. Optimal interpolation in that case means a system which is sequential, but the covariance, the background error covariance matrix, D of PV, is kept constant in time. It does not evolve, contrary to what it does in Kalman filter, and contrary to what it doesn't have the feature of variation and assimilation, which I have not described yet, which means that the temporal evolution of the uncertainty is taken into account over an assimilation period, as I will describe more precisely tomorrow. And it also uses extended Kalman filter and ensemble Kalman filter. So this should be a very good implication. Now they are not available. There is a user guide which I actually asked David to correct because there are a number of questions which are not even readable, so there is no point I circulate it at this stage.
Okay, good. That gives you then some overview of what it will be about. That gets ready for discussion. Is there any comment from your side or any special guidance that you would like us to take into account? Or things that you would like to try yourself?
Could you talk something about like assignments or projects, or what's the plans for next week?
Yes, Olivier, could you answer that question? The question was whether there will be assignments or whether it will be just a reproduction of.
Oh, well, I must suggest assignment, but I mean, it's up to you. I mean, I must suggest, of course, whenever are precise things to do, but I will not consider them as, formal assignments. But I must suggest specific experimental or specific work to do.
Yes. And there will be the opportunity perhaps also to have, some people have their specific plans, of course, for their future work. So they should and could use the opportunity maybe to ask for specific guidance also. Whether or not it can be directly used, just please.
I think one thing that would be very useful would be some kind of exercise with asynchronous observations. So observations which are not all in the time step, or maybe they are in some kind of multiples of a basic time base.
Yes. There is possibility in our software, package to vary the distribution of observation, the errors and the observation, and to do all kinds of experiments in this kind of thing. Right.
And maybe where we can interpolate the data into a grid.
Well, in the case, there is no grid. We are only systems with a small number of parameters which are not meant to represent some film in a special some films in a special domain. So the question of waypoint and the interpolation of waypoints does not exist and is meaningless in the context of what I'm going to put. It's just the question of dynamical evolution, in particular in a character system, and how assimilation then can deal with a system which has a chaotic evolution.
Okay.
Yes? Any other comments? And you are free, of course, to use and try other software which allows you to learn something about the underlying physics and show us to the lecturers or other experts at the program here. So that might perhaps also help you forward in your future research. Yeah, that's I think all I was expecting for today.